I'd like to talk about quadratic functions. Recall that a quadratic function is a function that can be written in this form. F of x equals ax squared plus bx plus c, where a, b, and c are just real numbers, and of course a can't be 0, otherwise your quadratic term goes away. The graphs of quadratic functions are parabolas, and in this video I'm going to focus on how to find the vertex of a parabola and how you can find the x-intercepts. So let's look at this first. Each quadratic function can be written in this form. And when the quadratic function is written in this form, it's called vertex form, and the vertex is just at hk. And the reason for this is that when the quadratic function is written in this form, we can just use our transformations to shift our parabola right or left and shift it up and down. So let's look at an example. We'll find both the vertex and the x-intercepts for this particular function. Recall that the function written in this form lets us know that the graph of the parabola has been shifted left 5 units and down 4 units, which is why we would say that the vertex is at the point -5, -4. In other words, the opposite of the number that we see here, comma, this number right here. So we have our vertex. Let's move on to the x-intercepts. To find the x-intercepts, we do what we always do, and that is set y equal to 0. In this case, our f of x is playing the role of y. So we have 0 equals x plus 5 squared minus 4. And of course, you have a few ways to solve this quadratic equation, but I'm going to use my square root property. Let's add 4 to both sides. Take the square root of both sides, making sure we put our plus or minus in. So we have plus or minus 2 equals x plus 5, or x equals -5 plus or minus 2. Let me come over here so I don't write too low. So my x values are -5 plus 2 and -5 minus 2. Whoops. Let me erase that. -5 minus 2. So we have x equals -3 and x equals -7. So our x-intercepts are -3, 0 and -7, 0. Using the vertex and the x-intercepts, that would be enough to come up with a respectable graph of this parabola. -5, -4 is our vertex. I'd put -5, -4 about right here. Our x-intercepts are at -3 and -7. And I could sketch my parabola. And certainly you could do more, plot a few points, find the y-intercept, but this is a reasonable graph for this particular function. Let's move on. For this example, our function will be y equals 1/2 x squared minus 7, and the directions ask us to find the vertex and x-intercepts again. I hope you recognize that this is also in vertex form. Remember, vertex form looks like this. Y equals a times x minus h squared plus k. Now, our h for this particular problem is 0. In other words, there has been no horizontal shift of that parabola. And our k value is -7. So our vertex is at 0, -7. Now let's find our x-intercepts. We set y equal to 0, and we're solving 0 equals 1/2 x squared minus 7. I'll multiply by 2. So I have 0 equals x squared minus 14. Add 14 to both sides, and take our square root. So we have x equals plus or minus the square root of 14. So our x-intercepts are at plus or minus the square root of 14, 0. So we could do a very quick and reasonable sketch of this just using the vertex and x-intercepts. So the vertex is at 0, -7, which is of course also the y-intercept. And our x-intercepts are at square root of 14 and negative square root of 14. And we draw our parabola. It should be a little bit smoother down here at the vertex. And this one is complete. Let's look at this one. Y equals x squared minus 4x minus 5. I hope you notice it is not in vertex form. So I don't know what the transformations are that have happened on this particular parabola. So our job is going to be to transform the equation into vertex form. Remember, we want it to look like this. That will require that we complete the square. So we get this nice perfect square right here. So let's do that. Now I know how to complete the square for a quadratic equation. And sometimes people will add 5 to both sides to get rid of that 5. But I'm not going to do that. There really isn't any need to put that -5 on the other side. I'm just going to slide it over and make space for the number that I do want to complete the square. Because notice, I want the y all by itself right here, just as it is right here. So I didn't really want to add the 5 over to this side. But in order to complete the square, remember we take half of -4 and square it. Half of -4 is -2. -2 squared is a +4. So we will add 4 right here. So I could add a 4 to the other side so that it will be using the addition property of equality and hence the equation still balanced. But I want the y to be by itself, so I'm going to choose not to do that. So let me erase that +4. But then you're thinking, well, I can't just add 4 to one side. You absolutely cannot. But what we can do is add 4 and subtract 4 from the same side. So we have a net change of 0. And now we have completed the square right here. So we'll rewrite the equation as x minus 2 squared. And then we'll do the arithmetic right here. That's -9. And we have the equation in vertex form. So our vertex is looking at us. It will be 2, -9. Let's go on and find the x-intercepts. You can choose to use any form of this quadratic function you'd like in order to find the x-intercepts. I can use this form here or this form here. The results will be the same regardless of which one you choose. I just look to see which one I prefer. I do notice that this one is factorable, so I would probably set this y equal to 0. If I didn't notice that it was factorable, or if it didn't seem very nice for factoring, I would set this one equal to 0. So here we go. We're going to find our x-intercepts. I mentioned it was factorable, so we'll have x minus 5 times x plus 1. So we have x equals 5 and x equals -1 as the x-coordinates of the x-intercepts. So as ordered pairs, the x-intercepts are 5, 0 and -1, 0. A quick sketch of this parabola would look like this, 2, -9. Let's see, 1, 2, 3, 4, 5. So 2 is right here. I'm going to put negative 9 down here. Our x-intercepts are at 5 and negative 1. I'm going to draw my parabola. I could make this a little bit better by finding the y-intercept. It didn't ask me to, and in fact, it didn't even ask me to graph it, but I just wanted you to see that. But remember, anytime you want the y-intercept, you make your x value 0, so you can substitute x equals 0 in, and you'll find this is negative 5. Let's move on to the next one. Our function is f of x equals x squared plus 18x plus 50. It is not in vertex form, so let's put it in vertex form. That 50 is not the number that completes the square, so I'm going to just slide it over and make space for the number that does complete the square. I take half of 18, that's 9. 9 squared is 81, so I will add 81 and subtract 81 from the same side. So I will have a perfect square right here, and my function looks like f of x equals x plus 9 squared minus 31. Now that our equation is in vertex form, I can just state the vertex. It is at negative 9, negative 31. Now let's move on and find the x-intercepts. The x-intercepts we can find by setting y equal to 0, or in this case, f of x equal to 0. I can set it equal to 0 here or here. I'm looking back here and I see that this is not factorable. So I'm going to choose to set the f of x equal to 0 right here, and the equation will be fairly simple to solve. So I have for the x-intercept, I have 0 equals x plus 9 squared minus 31. I'll add 31 to both sides. Take the square root. And I have plus or minus the square root of 31 equals x plus 9. Subtract 9, and we have negative 9 plus or minus the square root of 31 for the x-intercepts. So as ordered pairs, that is negative 9 minus the square root of 31, 0, and negative 9 plus the square root of 31, 0. Now let's draw a graph, even though it doesn't ask us to, just so that we can see that the pieces fit together nicely. So I'm going to put negative 9 right here and negative 31 down here. So there's our vertex at negative 9, negative 31. And our x-intercepts are at negative 9 plus the square root of 31 and negative 9 minus the square root of 31. The square root of 31 is about 5.6. So this one would be negative 14.60. And this one would be about negative 3.40. I just wanted to know roughly where they are so I know where to put them on my x-axis. So let's see, negative 3.4 we'll say is about right here. And negative 14.6 is about right here. And I could draw my parabola through those points. And I would label them with the exact values. Negative 9 minus the square root of 31, and this one is negative 9 plus the square root of 31. Our next example will be f of x equals x squared minus 12x plus 41. Why don't you pause this video and see if you can put this one in vertex form? Let's see if you got the same thing that I'll get. Let's slide that 41 over So we have f of x equals x squared minus 12x plus 41. We take half of negative 12, that's negative 6. Negative 6 squared is 36. So I'm going to add 36 and subtract 36 from the same side. Our next line will be f of x equals x minus 6 squared. And we do the arithmetic with negative 36 plus 41, and we have plus 5. So our vertex will be positive 6, positive 5. Let's find our x-intercepts. It doesn't look like this expression right here is factorable, so I'm going to set y equal to 0 right here, or in this case again, f of x equal to 0. So we have 0 equals x minus 6 squared plus 5. Subtract 5. Take the square root of both sides. And right here we come to a screeching halt because we recognize that we have non-real values. So I don't need to continue because x-intercepts need to be real and the x values here will be non-real. So there are no x-intercepts for this problem. Let's see why not. Our vertex was right here at 6, 5. This parabola opens up because our leading coefficient, that's this coefficient right here, is positive. And if we have a parabola that opens up with the vertex at 6, 5, it's opening this direction and won't cross the x-axis at all. So it makes sense there are no x-intercepts. So I'd have to do a little bit more work to figure out exactly what the graph looks like. I'd probably use the y-intercept, but I'm not going to take the time on this one. Let's move on. This function is f of x equals 2x squared plus 4x minus 12. You'll notice it's not in vertex form, so our task is going to be to put it in that form. There's an extra little wrinkle with this problem, and that is that this leading coefficient is not 1. We'll handle that in a minute. Just as in the previous problems, I'm going to slide the constant over. I do not want it to be involved with completing the square. So I have f of x equals 2x squared plus 4x minus 12 with the 12 out of my way. Now we have to deal with the fact that the leading coefficient is not 1. Remember, when you're completing the square, you want the coefficient to be 1. So one thing I could do is divide by 2, but then if I divided the right-hand side by 2, I'd have to divide the left-hand side by 2, and I'd mess up my f of x over here. I'd have f of x divided by 2, and I don't want to do that. So instead, here's what we're going to do. We'll factor out the 2, but just from the first two terms. I'm factoring out the 2, and then I'll have x squared plus 2x in the parentheses. I'm going to close parentheses, leaving some space, and then I still have the minus 12. So the two equations are still equivalent. I've just factored out 2 from the first two terms. Now I look at this coefficient right here and determine what number I need to put right here to complete the square. I take half of 2, that's 1. 1 squared is 1, so 1 is the number that completes the square. So let's put in the plus 1. But notice the 1 is inside the parentheses, so I didn't really just add 1. I've just added a 2 times 1. I have just added a 2 on the right-hand side. So to balance it off, I'm going to have to subtract 2. So that's the big deal on a problem that looks like this. Making sure that you're clear that this number is being impacted by the number outside the parentheses. So let's continue. We have f of x equals 2 times x plus 1 squared minus 14. And our equation is in vertex form. So our vertex is -1, -14. Remember, this coefficient will not affect the vertex when it's in vertex form. It affects how stretched or compressed the parabola is when you graph it. Let's find the x-intercepts. I'm going to set f of x equal to 0 on this line right here. So I have 0 equals 2 times x plus 1 squared minus 14. Let's add 14 to both sides. I want to divide by 2 before I take the square root of both sides, so let's do that. So we'll have 7 equals x plus 1 squared. And now we'll take the square root of both sides. Plus or minus the square root of 7 equals x plus 1. And we have x equals -1 plus or minus the square root of 7. And we could graph it. I think we've graphed enough that you would know how to graph this if you needed to. So I want to do a couple more examples where the coefficient of the x squared term is not 1. So let's move on. Our function is f of x equals -3x squared minus 30x minus 17. And this time let's just focus on finding the vertex. We have found the x-intercepts on a number of problems. Notice it is not in vertex form. So let's transform it into vertex form. Start by sliding that -17 over. So we have f of x equals -3x squared minus 30x minus 17. Since our coefficient of x squared isn't 1, we're going to factor out that coefficient. So we will factor out -3. F of x equals -3 times the quantity x squared plus 10x. Close those parentheses, and we still have the minus 17 sitting out there. Take half of 10, that's 5. 5 squared is 25, so we're going to add 25. But notice that's not really a true 25, because that's really a 25 being multiplied by -3. So I have really just added a -75. If I've added a -75, I need to add a positive 75 to balance it out. So our function will read f of x equals -3 times the quantity x plus 5 squared plus 58. Our function is in vertex form, so we can just state our vertex. It is -5, 58. Let's look at one last problem. It is f of x equals the opposite of x squared plus 6x plus 20. If you're feeling ambitious, turn off the video, give it a try yourself. See if you can put it in vertex form and name the vertex. Okay, here, let's go. I'm going to slide that 20 over because we don't want it involved in completing the square. Our coefficient of our x squared is not 1. It's a -1, so I need to factor it out. So I'm factoring out a -1. You don't actually have to write the 1 part, so I have in parentheses x squared minus 6x. Close my parentheses, and I still have my 20. I'm taking half of -6, that's -3. -3 squared is 9, so I'm going to write +9. But notice I really didn't add 9. I have really just put in a -9. So to balance that out, I need to put in a +9. Our function now looks like f of x equals the opposite of x minus 3 squared plus 29. So we can name the vertex. It would be 329.